Welcome to Calculus 2. This is Math 2262. Before we start on the new material, I want to do a somewhat quick review of what should have been covered at the end of your Calculus 1 class. And we're looking at integration. We're going to start here with a few different properties. When you are integrating, there's a few things that are going to come in handy from time to time, and there's 7 properties that are here on the first page. And I do have pictures of most of them at the bottom of the page. The ones that we will use the most often are going to be numbers 3 and numbers 4. Number 3 says that if you have a constant k inside that integral, you can then pull it in front. We're going to use that quite often. And then number 4 has to do with the sum and difference. If you've got two functions that are either added or subtracted inside the integral, you can set up two integrals that are either added or subtracted from one another. Those we're going to use the most often in the class, but the others will come into play from time to time. Now, I want to actually move on to the second page here just to go over some examples of those properties really quickly. One of the properties, and this should make sense, if you think about integration as finding the area under a curve, one of the properties says that if you integrate from a number to itself, you're going to get an area of 0. And again, if you think of this as an area, your upper and lower bounds are going to mark the left and rightmost points of the area that you're integrating. Well, if they're the same number, that distance between them is 0, and 0 multiplied by the height is still going to be 0. So that's one of those properties. Another property says that if you flip the upper and lower bounds, you're going to get the opposite value from your original area. So for instance, when you integrate from 1 to 5, the function f, it says that the value is 6. If you flip the order of those, you're going to get a -6. And you could think of that property very similar to just subtracting two numbers. 6 minus 4 is 2, but 4 minus 6 would be -2. This third one here, this one I mentioned on that previous page, I've got the number 3, which is a constant inside that integral. I can very easily bring it in front. So now we've got 3 times the integral from 1 to 2 of that f of x. We know that this value here is going to be -4 because we're given that information. So we're just going to have 3 times -4 or -12. Moving to the bottom row here, the first one is asking for the integral from 2 to 5 of the f function. Well, we're not given that explicitly, but we can use what works out very similar to the transitive property to find it. So one of the properties on the previous page says something similar to this. If I look at the integral from 1 to 2 of f of x, add to that the integral from 2 to 5 of that same function, what I'm essentially doing is I'm integrating now from 1 all the way to 5. So that's what it's going to equal. We are given that the integral from 1 to 2 of that f function is going to be a -4. What we don't know is this middle part here. And then we're also given that the integral from 1 to 5 of that f function is going to be 6. So -4 plus this missing value equals 6. Just solve it like you would an algebra problem. Add 4 to both sides. And you'll find that the integral from 2 to 5 is going to be equal to positive 10. The next one now, this is asking us to find the integral from 1 to 5 of f of x minus g of x dx. So we have values from 1 to 5 of the f function and the g function, so you're just simply going to subtract. So this is the same thing as if you were to write the integral from 1 to 5 of f of x dx minus the integral from 1 to 5 of that g function. So it's simple subtraction. It's going to be 6 minus 8, or -2. And then the last one, it's very similar to the previous one, except you're multiplying the whole thing by 4. So again, you could write this as 4 times that entire thing. And we just found out that the integral from 1 to 5 of f of x minus g of x is -2. So we're just going to take 4 times -2, which is -8. So like I mentioned before, some of these properties we will use more often than others as we do some integration, but we're going to see them pop up, all of them from time to time. Like I said, though, some of them more often than others.